Good morning, students. So today, after a break, we will continue our topic. So in the last class, we have studied the mathematical formulation of an LPP, linear programming problem, and means how we formulate it mathematically, and the general form of an LPP we have studied. Now today, we will solve the problems based on linear programming problem, and we will solve it by graphical method. As we have studied the graphical method, how we have to make the graph and find out the feasible region, and from that feasible region we have to find the maximum or minimum point from the corner points of that feasible solution, whether it is maximize or minimize. Okay, so the very first question that we solve today is this question is directly given in the mathematical way. Okay, here you are not given the sentence or statement questions from which we have to formulate it mathematically. First we will do the very simple questions that are given directly mathematically. So the problem is maximize z equals to 3x1 plus 4x2. Okay, so this is the question you have to make. This is your objective function, z equals to 3x1 plus 4x2. Subject to means now we will write the constant subject to 4x1 plus 2x2 less than equal to 80. This is the first constant. 2x1 plus 5x2 less than equal to 180, x1 greater than equal to 0 and x2 greater than equal to 0. These are non-negative constants, right? So this is our question. It directly given us mathematically. Objective function to diya ase aru subject to the constants. So the very first step that we have to solve this problem, first we have to consider the inequalities as equalities. মানে এই inequalities sign কিতাক আমি equality কৰি কিনে graphically solve কৰিব লাগিব. So we go to the solution. The very first step, consider all the inequalities. Consider all the inequalities as equalities. We have to consider all the inequalities as equalities. Okay, so our first is 4x1 plus 2x2 equals to 80. Now we have to solve. This is the normal equation in two variables, x1 and x2. We have to solve is both for x1 and x2. In our lower classes we have solved. So how we solve it? You can also simplify this. It becomes 2x1 plus x2 equals to 40. Okay, when you take 2 common, so this is x1 and x2. If you take x1 0, then your x2 is 40, and if you take x2 0, then your x1 is 20, right? Then the next constant, our next constant is 2x1 plus 5x2 is equal to 180. Okay, this is our second constant. Now again we have to solve it like this way for x1 and x2. This is x1, this is x2. So when you put x1 0, you get it as x2 36. When you put x2 0, you get x1 90. Okay, so now we get 4 values of x1, x2. Now we plot the graph. How we plot the graph? We draw maximum x2 we have 40 and x1 maximum is 90. Okay, you can consider x1 is the simple along x-axis and x2 along y-axis. So we draw the graph. So this is the origin, this is x-axis, this is y-axis. So we can take the difference of 10 units, so it becomes 10. So our graph will be 10, 20, 30, 40, 50, 60, 70, 80, and this is 90. Here also this is 10, 20, 30, 40, 50, 60, 70, 80. Okay. So the first point is x1 0, x2 40, means this is x1, you can take along x and x2 along y, this is 40. So this is the point. This point is 0, 40, right? Now the second point is 20, 0, means this is the point 20, 0. Now next x1 0, x2 36, this 35, then this is the point, it is 0, 36, and the next one is 90, 0. Okay, so we draw the line. For the first one, our line is, you have to draw this line with the help of a scale, otherwise your graph will be not proper, will not be proper. And our next one is this. Okay, so these two are our graphs. Now we find out the feasible region. How we find out the feasible region? Here you see for x1 the first constant is less than equal to, means this is the graph for, this one is graph for 4x1 plus 2x2 equals to 80, and this is for 2x1 plus 5x2 less than equal to 180. So here you have less than equal to, it means your graph will be shaded in the downward direction, both the graphs. Okay, here you shade this one also, this graph will be shaded for this like this, and for this one you will shade in the downward direction, because since it is less than, in this way you will run. And two non-negative constants are x1 greater than equal to 0, means greater than means it is in the upward direction, and from here x2 it is in the positive direction. So the common region that we get from both these four constants is this. This is the common region we get. Okay, so this is the common region, we can label it, this is the shape. Here 4 points we have, this is the point A, this is point B, this is C, and this is the point D. So these 4 are the corner points. You have, this is our feasible region, and these 4 are the corner points, and in these corner points now we have to find the value of the objective function, and from that we have, from there we have to find out which is the maximum point at which the value of the z is maximum, right? So now these three we have, this is 0 0, b, c is 20 0, a is 0 36, but what about d? We have to see what is d. I think it is near about 4 or 5, and from here it is 35. Okay, so it is near about not 4, it is, you can take it as 3. Okay, because here is the point you get, this is 3 and this you can, since this is 36 you can take this is 35, so your point become 3 and 35, right? Now we have to find out the value of z. Here we write the corner points, and z equals to 3x1 plus 4x2. Okay, now the first corner point is a, this is 0 36, b it is 0 0, c is 20 0, and d is 3 35. and the value of z is 0 4 6 24 2 144, it is 0, this is 60, and this is 9 plus 20 0 2 140 plus 9, it is 149. Okay, so these are our value for these 4 our value of objective function at these 4 corner points, and which is the maximum value we get at the point 3 and 35. This is the maximum. It means the maximum value of the objective function is 149 at x equals to 3 and y equals to, or x1 equals to 3, x2 equals to 35. Okay, so at last you write, therefore the maximum value of objective function, the maximum value of objective function z is 149 at x1 equals to 3 and x2 equals to 35. Okay, and here a b c d is the feasible region. So in this way, this is very simple, nothing to worry about these problems. These are quite bit longer, but they are easy. Okay, so first we have to consider the inequalities as equalities, and then we solve it and plot the graph. From graph we have to find out the feasible region. How we find the feasible region? We shade the graphs, we shade the lines according to the inequalities, then we get the feasible region, that is the common region from the shaded portion of all these constants. Then we get the 4 corner points there, and at those corner points we have to find out the value of the objective function. Since it is a question of maximization, so we find out the maximum value at which point, means we find out at which point we get the maximum value of z. Okay, so in this way we have to proceed. Now we will do the next problem, so it becomes more clear to you. Next we will do the similar type problem, so that the concept become more clear to you. Maximize z equals to 8x1 plus 5x2 subject to x1 is than equal to 150, x2 less than equal to 250, 2x1 plus x2 less than equal to 500, x1 comma x2 greater than equal to 0. Okay, so here your question is, again you have to maximize the objective function. Now we will solve this question. So the very first thing, consider all inequalities as equalities. Means we have to consider x1 equals to 150. Here nothing to solve, directly we have x1 equals to 150, x2 equals to 250, and the third one is 2x1 plus x2 equals to 500. Here we have to solve this. This is x1, this is x2. So when you take x1 0, your x2 becomes 500. When you take x2 0, your x1 becomes 250. Okay. Now we plot the graph. So here I think we have to take the 50-50 unit. Maximum we have x1 250 and x2 is 500. So I think if you take 50, then 100, 150, 200, 250, then 300, 350, 400, 450, 500. This is x1, x2 is again, we have to take 50, 100, 150, 200, 250, 300, 350, 400, 450, 500. Okay, now the very first one we have x1 equals to 150. This is your x1 along x-axis and along y-axis is x2. So you have x1 equals to 150. It means this is x1, so 150 means it is like this is straight. We have this one. This is your x1 equals to 150, x2 equals to 250, so it is this. This is your 250. So this is your x2 equals to 250. Next we have x1 0, x2 500. This one is 0, 500. Next 250 0. This is your 250 0, and it comes out to be like this. The graph we get. Now we have x1 less than 150, means now we have to shade. X1 less than means in this side you have to, in this way it is shaded, right? X2 equals to less than equal to 50 means it is in the downward direction. In this way, x1 plus x2 less than 500 means it is in this direction, and x2 greater than equal to 0 means these are in this. So ultimately we get the feasible region, this one. This is the feasible region, and these are the corner points. These are the corner points. The points are, this is yours 150, 0, this is 0, 0, this is 0 to 50, and this one is near about 150 and 200. It is, you can take 150, 200, and this one is your 150, 125, and this is 125 and 250. Okay, so these are the points we have. Now we calculate the corner points. So our feasible region is, you take it as O, A, B, C, D. O, A, B, C, D is the feasible region. Feasible region, and the corner points, and the Z is 8x1 plus 5x2. Corner points are 0, 0, 0 to 50, 150, 0, 150, 200, and 125 and 250. Now we find the values. So the first value corresponding to 0, 0 is 0. The next one is 1250. The next is 1200, and next to this is 1200 plus 1000, it's 2200, and the last is 1250 plus 8 into 125, it's 1000, so it will be 2250. So this is the maximum value of objective function at the point 125 and 250. So the objective function is maximum at x1 equals to 125 and x2 equals to 250. So in this way we will do the linear programming problem which are given directly in mathematical way, right? In the next class we will do how we formulate it mathematically from the statement question. Okay, I have given you the example in the previous video, but practically how we solve we will do in the next class. Thank you.